Hey everyone, a very good evening. So before I start this session, first let me know if I'm audible and visible to everyone out there or not. Yes. All right. Yes, Dhairya Abhani, good evening. Hello Prakhar Sharma. Hi Saran Teja. Yes, hi Ayush Biswas. Yes. Good evening Anshita, I'm doing good. Thanks for asking. Yes, good evening Anshita. Yes. Yes, hi Pratyush Bajpai. Dhairya is saying, yes ma'am, you're fully audible and visible. Prince Yadav is here. Sara Naseem, hello. Hi SK Cuber. Hi Daman Kumar. Hi Era Gupta. Hi Elena Hashmi. Alright, great. So there is no glitch at all, so we can continue. My name is Khushbu and a very warm welcome to yet another wonderful session. So you know what today's session is about, right? So today we'll be covering the concepts and a few questions on surface areas and volumes. So we have divided this chapter into two parts. Today we are discussing part 1 of this chapter, right? Alright, so without wasting any more time here, let's start the session. So this session, as we know about, we will be talking about the areas and volumes about the different figures, right? So let's first understand what figures are and how are they actually formed. So let's take a point here and let's take more points so that they form a straight path. So what we get here is basically a line, right? And it's basically, if you see, it's a one-dimensional figure, right? It is 1D, that means it has a length of 1 unit over here. Mohammad Anzar Khan, absolutely, we have Menti today. Chavi Sharma, ma'am, do you know this chapter is very difficult? Literally, there are lots of formulas and all. This chapter is very easy. Yes, one thing you need to remember is the formulas. But today I'll show you, we will be visualizing it, how these formulas are actually formed. Yes, line is one-dimensional. Alright. Now what we will do here is, let's stretch this line towards the right. And what do we get here? We get a figure form that is actually a square and it's a two-dimensional figure. It is a 2D figure which has a length of 1 unit and width also of 1 unit. Both length and width are going to be same in this case, right? Alright. Now we know that 2D figures have areas as well as perimeters, right? We are all aware of it. But in today's session, we will be focusing on the 3D figures. We'll be focusing on solid figures that has a depth as well as height. Now, let's take a 2D figure and from that we will make a 3D figure. Let's see that. So here you can see that in a 2D figure, when height is also, when we have a 2D figure over here, when we keep overlapping them with of the same dimension of the same figure, then what we see here is that we get a 3D figure which has a height as well. So here we can see that all length, breadth and height, each one of them is same, that's 1 unit. Tree plant, not too much. Yes, you have just missed just one slide we have just discussed till now. That you can watch later on. You can see the recorded session. We will be discussing the formulas, Ritik Bansal. Wait, yes. Alright. Yes, how to remember formulas? Part Scheller, we will visualize them today. Don't worry. It will be very simple for you to remember them. Okay, alright. Now, we know that 3D figures or solid figures, how can we classify them? So, we have classified them into 3 categories. The first category is all the flat surfaces where we have cube and cuboid, right? Another category is where we have only curved surfaces, which includes only a sphere. And the third category that we have is that includes a combination of flat and curved surfaces, which includes cylinder and a cone, right? So in today's session, we will be discussing the flat surfaces and flats and curved surfaces. I'll be talking about cuboid, cube and a cylinder in today's session. Yes. Yes, it's going to be fun to visualize them. All right. Now first, we will see, we are just aware of how a 2D figure is converted into a 3D model, right? By just overlapping the same figure of the same dimension on top of each other. Now we will see how a cuboid, which is basically a solid figure, a 3D figure is formed. So here we have a 2D figure, which is a rectangle. It's got a length as well as width. Now if I keep piling up these rectangles on top of one another and they're of the same dimension such that it reaches a certain height edge, what we see here is that we get a cuboid, right? Which has got length, width as well as height. So 2D figures have length and width only, but if you keep piling them up with the same dimension of the same figure, then height is also included in that. Yes. Byjus is one and the only great channel to learn new things. Thank you, Prince Yadav. Alright. So here we saw that how a cuboid is formed, how a 3D model is converted from a 2D figure, right? Now, as I said that 2D figures have got areas. Yes, they have got areas, they have got perimeters, right? So in case of cuboid as well, we have areas, and that area is classified into two categories. We have surface area, which is basically the total surface area, right? And we have lateral surface area, right? Like you saw that when you have a rectangle, you keep piling them up with the same dimension, the same figure, you get a cuboid that has length, width and height. Alright. Alright, so first we'll be discussing each one of them one by one. Let's first discuss the surface area. What is it actually? So here, let's take an example. Let's suppose we take a cuboid and we submerge that completely in a bucket which is filled with a green colored paint. And when you take it out, what you see is that all the surfaces of the cuboid are colored in green now. Yes. So when you say all the surfaces are colored in green, basically we are talking about the total surface area, or simply you can say the surface area. So when I say surface area, it is a closed figure. We are considering all the surfaces of the cuboid. Yes. Alright. Alright. So here, let's take a cuboid which is having different shades of blue representing different sides having different measurements. When we open this up and we check all the sides, what we see here is that in total I have got 6 rectangles over here. So this is representing area 1, area 2, area 3, area 4, this rectangle. This is area 5 and this is area 6. You can see that the measurements are also marked here, right? And you can see here different shades of blue, correct? Some is very light, some is a little darker than that. Yes. Now when you talk about the total surface area, we are considering all the 6 surfaces. Yes. So I'll be taking the areas of all the 6 rectangles that we have. So total surface area is going to be A1 plus A2 plus A3 plus A4 plus A5 plus A6, right? And when I add all them up, what we see here is that first of all, this area 1 and this area 5 are same. You see they are of the same color. So this has height and this is breadth. Similarly, area 2 and area 6 over here are same. These two rectangles. Area 3 and area 4 over are same. Basically, they have the same dimension. Alright. So, area 1 and area 5. To find out their area, since they are rectangles are nothing but their area is length multiplied by breadth. That is h times p. Similarly, for them it's h times l, and for them it's breadth times L. Yes, breadth times length. Cuboid mein, if you have a square, see here in cuboid, it is basically you keep piling up rectangles, right? Square say you can form a cube. Yes. I'll show you that also, Deepak. Don't worry. Yes, good evening, Harinder Policy Pehle. Yes. Alright. Devanshi Rai, Byjus is totally the best education system. Its visualization technique of teaching a student is really innovative. Thank you. And I'm a Byjuite and I'm proud to be a Byjuite. And thank you for such positive words. Alright, so when I told you that we are finding out the surface area, the total surface area, we are considering all the 6 surfaces. See, this is how you can remember this formula. When you open that up, you get 6 rectangles, right? I showed you that when you keep piling up rectangles, you get a cuboid, right? And a rectangle has an area of length times breadth. So simply, I'll put all the values here for all these areas. So we know that each of these areas is coming twice. That's why we have twice here. Now, if I take 2 common, I have h times p plus l times p plus l times h. That is the total surface area. Thank you, Nibha. That's okay. Whatever you have missed, you can watch the recorded session later on. We have Menti today. Gungun Kumari. Yes. Alright. So, when you talk about the unit of the surface areas, right? When we talk about the units, we know that areas are always calculated in square units. So whatever the area is, this is the total surface area, you have to put the units in unit square, whether it is centimeter or meter, whatever it is, that should be unit square over here. If breadth or height or length or height of, they can be squares. If the measurements are same, only then, yes. So this was about the surface area, that means total surface area. Now we will talk about in a similar manner about lateral surface area, right? So here again, we have a rectangle. We are piling up the rectangles of same dimensions on top of each other. Rectangle have different length and breadth, right? and then you get a cuboid. Yes. So which has a length L, width W, and height is h. Now when you open this up, what do we see here? We see that we get in all 6 spaces. You can see that numbers are marked on each of these spaces, right? Yes, that is also possible, right? So this is the top face, this is the bottom face. When we are talking about the lateral surface area, we are not considering the top and the bottom face. We're only considering the lateral faces, right? Exclude the top and the bottom one. So we are left with face number 1, 2, 3 and 4. So this is actually showing us the lateral surface area. So we add all them up, A1, A2, A3 and A4. And we put, so that means total area in green that we have. So once I put all their values, we have h times w plus h times w, h times l plus h times l. So twice of h we take out. We have w plus l inside the bracket. This is nothing but that's the lateral surface area for a cuboid. Yes. 2l plus bh, Anshita, that's correct, yes. All right. But now we'll talk about the units for lateral surface area. Since this is area, areas are always in square units. So again, this will also be unit square. Yes. All right. So this was about cuboid, right? We just saw how a cuboid is converted from a rectangle, from a 2D figure that is rectangle. We just visualized how this formula has been framed, this total surface area and lateral surface area, and what this is actually, right? Now in a similar manner, we will discuss the cube. So cube is another flat surface. It is also a 3D figure, just like a cuboid, right? The only difference here that we have, so what is the relation between a cube and cuboid? It's also a 3D figure. Cube is also a type of cuboid where all the dimensions, if you see, they have the same measurements. I think, Deepak, I have answered to your question, right? Where it's also a type of cuboid, but all the dimensions will have the same measurement. Thank you, Niranjana KP. Yes, Nibha Chaudhary, you can use B in place of W. Yes. Yes, Neha Kamble, I'm explaining that only. That cuboid is basically, cube is basically a cuboid only, right? It's a type of cuboid where you can see all the sides will have the same length. All right. So here, the only difference here is that now we will see how a cube is formed, right? So from a 2D figure, which is a square over here, I just said that all the length, width and height in a cube, they are equal. They all have the same measurement. So let's consider that as h. Suppose I have a square over here, which has a side length of h, and if I keep piling up squares of the same measurement on top of each other like this, right? Such that it reaches a certain height, that is s, what do I get finally? At the end, I get a cube. Yes, correct. So here I can see that again, cube also has 2 types of areas, that is surface area and lateral surface area. First I'll talk about the surface area. So we are talking about the total surface area over here, right? So here we have a cube, right? So it's a colored cube, right? It has different colors of blue, you can see, like we did in the cuboid. So when you open it up, you can see that each one of them has a side length of A. So for a cube, length, width and height, we know that they all are equal, right? Each one of them has a side length A. And what I can see here is that, so each one of them is a square, right? How many squares do I have? I have 6 squares over here. So area of one square is basically side square. That's A times A. So area is going to be A square. Since I have got 6 squares over here, so total surface area in that case, I mean surface area of a cube in that case is going to be 6 times A square. So that's 6A square. That's how we find out the surface area for a cube. Yes. Right. Total surface area is 6A square, correct? Yes. All right. Or if we add the floor to the lateral surface area of the cube. See, when you are adding, Pravmeet, if you are adding, you are saying to the lateral surface area of the cube. I'll just discuss that. So this is basically the area of all the 6 squares. Now, when you talk about the units for this, again, since we are talking about areas are always in square units. Doesn't matter whether it's a cube or a cuboid. Again, it will be 6A square unit square, right? Similarly, in a similar manner, I'm going to discuss the lateral surface area, right? So let's see what a lateral surface area is. Again, we have a square. I'm piling up the squares of the same dimension on top of each other, and at the end we get a cube. Yes? Now let's open this up. What I see here is that I have got 6 surfaces in total, where 4 surfaces are green in color, excluding the top face and bottom face. If we exclude them, what we get is we get the area of the 4 surfaces, which tells us about the lateral surface area. Yes? Alright. So when you talk about the lateral surface area, we are considering these 4 surfaces, right? So for the left face, again, all the dimensions are same. Each one of them is a square. It's going to be a square. For the right face, it's a square. For the front face, it's a square. For back face also, it's a square. I'm just excluding top and the bottom one, right? So area of all the 4 sides over here is going to be 4 times a square if you add all them up, correct? So this is about the lateral surface area. And now somebody just asked me if in the lateral surface area, that is LSA, if we include the bottom, I guess that's what you asked, right? Top or bottom. Obviously, all of them have got the same dimensions. If I'm including the bottom as well, so area of bottom would be what? That would be a square. So 4a square plus a square, that's going to be 5 times a square. See, that depends on the question. What information is given to you and what you need to find out, right? All right. So this was about cubes and cuboids. Correct. Navdeep Singh. Yes. Nipha Chaudhary. Yes, Anchita. That's the lateral surface area. One more surface I have added to it. Right. Let's suppose top or bottom. That becomes 5a square. Correct. All right. So this was about the flat surfaces, cube and cuboid. Now, as I said, I'll be discussing the combination of flats and curved surfaces as well. So now we will talk about the cylinder. So it's basically a combination of flat and curved surface, correct? So you can see how the cylinder actually opened up. So here, let's see that it's, we will talk about its curved surface area, right? Which is basically the lateral surface area. So this is a cylinder. It has got a radius r and height as h. Now when I open its lateral surface area, so what we see here is that we get a rectangle which has a width of h, but its length would be equal to the circumference of this circle, of this base area, right? That is basically 2 pi r. So the area of rectangle is what? That's length times breadth. Length is what? That's 2 pi r. Breadth is what? That's h. Area of rectangle is 2 pi r h. And we were talking about the lateral surface area of the cylinder, right? We opened the lateral surface area, we get a rectangle. That means I can say that the curved surface area and lateral surface area, or you can say area of rectangle over here in this case, that would be 2 pi RH. Yes? Correct? Yes, 2 pi RH. That's the formula for the lateral surface area. Alright. Now when you talk about the total surface area, right? We have a cylinder here. So here we will include the top and the bottom surface as well. So flat surface area over here, the top one and the bottom one. Each one of them is a circle. Its area would be pi r square. This area is also going to be pi r square. And this is what? In between, that's the curved surface area. So flat surface area is 2 pi r square when you add them up. Total surface area is curved surface area plus flat surface area. Right? So this is going to be 2 pi RH plus 2 pi r square. Yes. So I'll take 2 pi r common and we have r plus h inside it, right? Ruhi Gupta, can we also do 6a square minus a square? So you're talking about the previous question that we discussed? Yes, that can also be done. That is also correct. Right. So this is the formula for total surface area of a cylinder. Yes, hello Shivam. Okay. See, Fahima, curved surface area, we use this terminology for the curved surfaces, right? Like we have cylinder here. Lateral surface area, we use them for flat surfaces. Although meaning is same, right? We are not considering the top and the bottom one. Thank you, Suhani Dhruva. Yes. Total surface area and lateral surface area for a cuboid. Ratio if you have to find out. See, the dimensions would be given. If such kind of questions comes in the exam, the dimensions would be given. Just calculate them, put them in ratio, you will get the answer. Straight away, you do not have to put the formulas, right? Because in that case, you won't be able to cancel out anything. Navdeep Singh, we are not explaining hollow cylinder in this session. All right. So I think these areas are clear to everyone. Yes? Yes, Abhiditya sketch. I'll be discussing volume. Flat surface area, these are the flat surfaces, the top and the bottom one. Yes? You can say that as base area as well. Great. Suhani Dhruva is saying clear. Pratiksha MR, yes ma'am. Anshita, yes ma'am. Bishal Day, yes. Alright, alright. So now this was about areas of cube and cuboid and cylinder. Now we will talk about the volumes, right? So a 3D figure is basically a solid figure that will have volume, right? Now can you tell me what is the difference between the volume and the capacity of a 3D figure? What is the difference? Quickly. Yes. Taman Kumar, clear? Yes. Yes, I'm waiting for your answers. Volume में थोड़ी गड़बड़ है. Volume is easier than areas, I would say. Isn't it? Nibha Chaudhary, yes, we do have Menti. Once we are done with this session, then we will have a Menti quiz. Volume, area inside, the terminology that you are using, that's not correct. Mass of the figure, no. Both are same, units are different. No, Saranteja, there is difference. Volume in centimeter, meter, capacity in liter. Space occupied, how much it can. Perfect, amazing. Subhash Sajan, yes, volume is a space occupied, but capacity is how much it can hold. Absolutely. Right. So basically, let's suppose if an object is a solid, right? So the space that it occupies, that can be measured. So we call that volume, the space occupied by an object. Yes? Absolutely, Neha. Amount of space occupied by the three-dimensional object, we call that volume. Yes. Correct, Ruhi. Capacity, how much it can hold. Right. But on the other hand, if the object is hollow, that means interior is going to be empty in that case. So it can be filled with air or with water, like you can see in this example over here, right? And the water or air, whatever we are filling it with, that will actually take the shape of the container. Yes. So this actually tells us the volume of the substance that can fill the interior, that is actually the capacity of the container. Yes. Capacity is the amount that it can hold. Yes, Navdeep Singh. Whereas volume is a space occupied by the object. Right, so we know the difference between the volume and between the capacity now. Yes? Quickly give me a thumbs up if you have understood this. Yes, correct. 1 meter cube is 1000 liters, right? Quickly, yes, I'm waiting. Space. Lakshmi Jangir, Byjus classes is the best in the world. Thank you. I can see lots of flowers and smileys. Yeah? Abhiditya sketch is giving a thumbs up. Yes? Right, Devanshi is giving a thumbs up, right? Navdeep Singh, Anshita. Yes, Shikha Mishra, Ritvik Bansal. Thank you, Ritvik. MD Zafar, yes. Vanchika Sharma, clear ma'am. SK Cuber is giving so many thumbs up here. Yes, super clear, Gungun. Great. So this was the difference between the volume and the capacity, right? Now we'll visualize it, right? So here we know that a 3D figure is a solid figure. Just like we visualize the areas, in a similar manner, we will visualize volumes also, the formula for volumes. Alright, so here you can see we have a rectangle, and when you keep piling up rectangles of the same dimension, rectangle has a length and width, right? The same dimension on top of each other, you get a cuboid such that it reaches a certain height, that is h, right? So here a rectangle has length and breadth, whereas a cuboid has length, breadth as well as height. So simply when height is also included in that, then we get a volume. So base area multiplied with height gives us the volume. Yes? Yes, music full on by Vidit Kalra. Base area into height, that's volume. Yes. Thank you, Lakshmi Jangir. All right. Right. Now let's take a look at this. So just like we talked about the units of areas, they're always in square units. Similarly, we'll talk about the units of volumes. Just now we saw that it's base area into height, right? What is the unit for areas? I told you that areas are always calculated in square units. And height is just a single dimension. So here we will write a single unit with power 1. So when you bases are same, you multiply and there is multiplication between them, you add up the powers. So volumes are always measured in cubic units. Always remember this. Yes. All right. So this was about the units of volume. So it is basically base area of rectangle into height. When you take a look at its cuboid, right? We had a 2D figure, that's a rectangle over here. Yes, when you keep piling up the rectangle of the same dimension on top of each other, you get a cuboid which has length, breadth and height. So base area of rectangle into height gives you the volume of the cuboid. Yes. Alright. So this was about the cuboid, right? So here, what is the area of rectangle? That's length times breadth and its height is h. So volume is going to be L times B times h. That's the volume of the cuboid. So we all knew the volume of cuboid, right? You have been learning this for the past 2-3 years, I'm sure. I think since grade 6 or 7, you have been learning these things. But today we have visualized it. And when you visualize things, so basically you are able to remember them for a much longer time. Right? Fahima Anwar, ma'am, concepts are crystal clear. Great. Yes. Okay, so this was about the cuboid. Raj Nandini, ma'am, you're my favorite teacher. Thank you. Alright, now we will talk about a cube. So here we have a square which all have the same dimensions. All the sides have same dimension, that is A. Right? And when you keep piling up squares of the same dimension on top of each other such that it reaches a certain height, which is again A, so you get a cube. Yes, so base area of square into height gives us the volume of cube. So again, area of square is A times A. Its height is again A. So that's going to be A cube, which is the volume. Now, so volume of cube is nothing but that side cube. So here the side is A. So I'm going to write this as A cube. Again, volumes are in cubic units. So it would be unit cube. Yes, Badal, pehchan liya. Yes, Jayesh. You want me to repeat once more about cube, right? So here you can see we have a square, right? We have a two-dimensional figure, that is a square over here which has a side length of A. Now when you keep piling up squares of the same dimension on top of each other, you get a cube, right? And this cube also has the same height which is A, because cubes are made up of squares of the same dimension, right? Yes. So here it's going to be area multiplied by area, base area multiplied by height. So what is the area of square? Base area is nothing but that's a square. That's going to be A square, and height is what? That is A. So it's going to be A cube. That's how we are getting its volume. Not yet, Ritik Bansal. We haven't done it yet. Thank you, Nibha. Pushkarini, first calculate it, then write down the units. Yes. Rishika Soni, yes. Diksha is giving a thumbs up. Ruhi Gupta, it's very interesting. I'm glad that you're actually liking it. Ritvik, okay ma'am. SK Cuber is giving thumbs up. Yes. I can see strawberries and cherries over here. Prakhar, thank you. Prince Yadav is saying clear ma'am. Nibha is saying clear. Great. So this is how we are getting the volume now of a cube. Now we'll talk about the volume of cylinder also, right? So here we have a circle. Circle area is what? That's pi r square. We all know it, right? Now if you keep piling up circles of the same dimension on top of each other such that it reaches a certain height h. So what do you get? Simply its area multiplied the height. So volume of cylinder, that's going to be pi r square h. That's how a cylinder is formed, you see. Yes. Arush Kumar, that will also be a 3D figure, right? Abhiditya, chapter is easy, but calculations. Yes, that's the most challenging part. I know. Alright. So this was about the areas and the volumes of cuboid, cube and cylinder. So we have covered these 3 solid figures today. Alright, now it's time. Let's solve some questions so that you get a better understanding. You should know how to apply them in questions, right? After that, we are going to have the Menti quiz. Yes? Thank you, Suhani Dhruv. So, 2 cubes each of side 4 cm are joined end to end. Find the surface area of the resulting cuboid. So, let's take 2 cubes over here to understand this, right? Each one of them has a side of 4 cm. All the side lengths in cube are same, right? Length, breadth, height, all are same, right? Correct? All of them are same. Now it says, let's join them end to end. So we are joining their edges like this. See, once this is joined, the height will remain the same, 4. Width will remain the same, that will not change, correct? But the length over here, this is 4 plus 4, that will become 8 centimeters, correct? I hope this is clear to everyone. Daman Kumar, we will solve a few questions, then we will start with Menti. Right? Okay, I can see the answers coming up. Alright, so we have a cuboid over here which length 8 and width 4 and height is also 4. So total surface area of the resulting cuboid, we are considering all the 6 surfaces. So we'll find out the total surface area. Put the formula, substitute the values. What do you get? You get 2 times 32 plus 16 plus 32. That's going to be 160 centimeter square. I could see students were writing 180 centimeter square. Yes? Answer is 160. Kanika Thakur, it's not 128 meter square. First of all, unit are in centimeter, right? Unit has to be correct and there is some calculation mistake that you are doing. Check it one more time. Diksha, Daman, yes, Nitin, SK Kuber, Lakshmi Jangir, Prakhar, Shikha Mishra. Yes. Alright. So that's how you can find out. And this is one of a very important question from exam point of view also. Alright, let's take a look at the another one. Find the height of the box if the cost of painting the box at the rate of rupees 10 per meter square is rupees 10,000. If the given length is 10 meter and breadth is 5 meter. So we are talking about a box over here, right? So the question says it has a length, it has a breadth, right? So since it has a length, it has a breadth over here. So it's a box and if cost of painting the box at the rate of 10,000 per meter square. So definitely length and breadth are different. Definitely it's a cuboid, correct? Alright, so we know about the surface area of a cuboid. That's 2 times HB plus LB plus LH. Cost of painting would be total surface area into rate per unit square, right? If you know the rate per unit square, you multiply that with the complete area, you will get the total cost, right? Okay, so total cost is given to you. Per unit cost, per meter square cost is also given. Let's put it here. So once I put it here, I'll write this as 10,000 divided by 10 meters square. That's going to be 1,000 meters square. This is basically the surface area of this cuboid over here. Now we have the surface area, total surface area. Using the formula of total surface area, I will get its height because we have length, we have breadth, we have the surface area also. So 1,000 equals to 2 times FH plus 50 plus 10H. Put everything here, 500 equals to 15H plus 50, 450 equals to 15H. H would be 450 by 15, that's going to be 30 meters. That's the final result. Lakshmi, some are saying 20 centimeter. How come it's 20? First of all, question is in meters. How can you get the answer in centimeters? You have to be very careful while writing the units. 30, 3030. How come it's coming 3030, Prakhar? 30 meters. Yes, Nibha, that's correct. Shikha, wrong answer. It's not 20. Gungun, Anushri, SK Kuber, Jayesh, Lakshmi. Yes, 30 meters is the answer. Sara Naseem, how I found out the surface area? See, question says that complete cost of painting is given, right? Complete cost of painting this box is given. And the cost per meter square is also given. If I divide them with each other, I'll get the surface area, right? That's going to be 1,000 meters square. Yes, Vanshika Sharma, I've repeated it one more time. So when you divide the total cost of painting with the cost per meter square, you get the surface area of this cuboid. When you have the surface area, just apply this formula of surface area. Substitute all the values that you have, then you will get the height of this. Yes, I hope it's clear to everyone, right? Alright, yes, Veer and Rishita, we will have Menti. Crystal clear, Deepak, Ashwarya, Soni, ma'am understood. Alright. Now let's take a look at the next question. If the cost of painting the inner surface curved surface area, we are talking about the curved surface area of a cylinder of height 70 meter at rupees 40 per meter square is rupees 8800, then the radius of base is. So we are talking about a cylinder over here, right? Cylinder which has a height is given, that's 70 meter. Total cost of painting is given again, just like the previous question, and cost per meter square is also given. Yes. Okay, so using that, we know that curved surface area is 2 pi RH, right? and how much area has been painted. So total cost divided by cost per meter square. From here I'll get the value of the area painted. So it is 8800 divided by 40, and this area is nothing but that's the curved surface area, because we have painted only the curved surface area that is mentioned in the question, right? Hi Paramveer. Yes. So simply put the values. 2 pi r is 2 into 22 by 7 into r into 70. That's equals to 220. 440 r equals to 220. So r over here, that's going to be 0.5 meter. That's the final answer. Yes, 0.5 meters. Correct. Subhash Sajan, Nibha, Anushri, Lakshmi Jangir. Right. Let's take a look at the next question. So two solids, a sphere and a cylinder, having equal curved surface areas. They also have equal radii, that's 7 centimeter. We have to find out the volume of cylinder. So when we talk about the volume of cylinder, what is volume of cylinder? That's pi r square h. Pi is a constant value, right? Radius we already have. We do not have its height. But height we can find out using this statement, a sphere and a cylinder having equal curved surface areas. So let's equate them. Curved surface area of cylinder and curved surface area of a sphere. So 2 pi RH equal to 4 pi r square. That's the curved surface area for a square. So from here, pi and pi will cancel out. This r will cancel 1 r. 2 will cancel out this 4. So we have h equals to 2r. Right? R is what? That's 7. So simply 2 times 7 is going to be 14 centimeter. That's the height for the cylinder. Now simply I'll find out the required volume. That's pi r square h. Yes. Put everything here. 22 by 7. 7 square into 14 over here. Right, this is not 12, that's 14. And on simplifying this, you get 2156 centimeter cube. That's the final answer. Yes, 14 centimeter, Lakshmi, that's the height, right? Correct. Nibha, correct. H is equals to 2r. Subhas, yes, 2156. Right, Ruhi Gupta. Yes, Vanita, right. All right. Correct, SK Cuber, Bhavya Chawat, right. Ashwarya Soni, what we have done here is, we have equated the curved surface area for cylinder and a sphere, because it's mentioned in the question. On equating them, you equate their formulas. That's 2 pi RH and 4 pi r square. Cancel out whatever you can. From here, you get h equals to 2r, right. R is given that 7. Put it here, you get the height. Now when you have the height, you have the radius, you have the constant value of pi also. Just put it in the volume of cylinder, you will get its value. Yes, that's the final answer. Correct. So all of you have understood, right? The areas and volumes for cuboid, cube and cylinder. So we have covered them very nicely. Yes. All right. Now, Menti quiz time. Yes. So we all know the drill. Go to menti.com. Clear, ma'am? Lots of thumbs up. Understood? Yes. Great. So what you have to do is go to menti.com. It will ask you for a code, and this is the code that you have to put it, 96332831. Quickly join it and write in the comment section that you have joined. Yes. Rudrakant Yadav, yes. Mukesh, so we have already covered the surface area and volumes. We have visualized how the formulas are actually coming. So please watch the recorded session later on. Kanika Thakur, joined ma'am. Nibha, joined. Ruhi, King of Status, joined. Music full on by Vidit Kalra, joined. Papiya Das. Quickly, quickly, everybody, I'm waiting. Yes. Yes, created, ma'am. Joined, great. Vidushmita Jena, me too. Ayush Biswas, Shikha Mishra. Yes. Am I Gamer, Saranteja. Yes. Hi, Bishal. Jenica Sweetie, Vaibhav Singh, Anushri Solanki, Vedika, Shikha, Abhiditya. Bishal has also joined. Jivant. All right. I can see that a lot of people have joined. Yes. Lakshmi Jangir joined. Prakhar. Yes, created. Loved the session. Thank you. Pranavi joined, ma'am. All right. Yes. Thank you, Nibha Chaudhary. I hope that whatever we have covered today, that's crystal clear to you. Yes? Yes, Priyani, Suryavanshi, yes, I'm waiting. Let everybody join. Veer and Rishita has also joined. Great. Hey, I hope you're able to see me now. You're able to see me and hear me. Yes? Nibha? Siddharth is saying joined. Sanjita, your first Menti. I hope that you would enjoy it. Music full on by Vidit Kalra. Yes, ma'am. SK Cuba. Lots of thumbs up. Okay, so I'm visible and audible to everyone. Yes? Alright, so let's start the quiz. I think I'm facing some... Yes, I can see a lot of people have joined. Alright. So let's start the quiz. So here we are going to have our first question now. Yes, what is the lateral surface area of a cuboid of length 6 cm, breadth 2 cm and height 3 cm? Quickly. It's a very simple question. All you need to know is the formula. Direct you have to substitute the values, but just be careful while doing the calculation. Yes, wrestling highlight quiz has started. I can see answers have come up. Okay, some are saying A, some are saying B. Okay. Yes. Lakshmi Jangir, this is not the formula to find out the lateral surface area. Time is up. Okay. And we can see that maximum students have given the right answer. That is 48 centimeters square. But still some are saying it's 40 centimeters square, 52 centimeters square and 42 centimeters square. Let's check the solution. So here we can see length, breadth and height is given. That's 2hb plus L. That's how we find it out. So put the values 2 times 3, 2 plus 6. That's going to be 2 times 3 times 8, which is 48 centimeters square. Yes? Gungun Tagore, yours is correct. Vanita, you have also given the right answer. Sanjita, right answer. Lakshmi, you were writing some the formula for volume of cuboid. Vidushmita, there might be some technical error, but at least you know how to solve it, right? B, yes, correct. Great. Let's take a look at the next question now. Now we have question number 2. That's okay, Lakshmi. Yes. So box of dimensions 8 meter by 7 meter by 6 meter can carry maximum what numbers of blocks of dimension 80 centimeter by 70 centimeter by 60 centimeter? A simple question but a calculative one. Yes. Pratiksha Emma, yours was correct. Kanika Thakur, yes. Nibha has also given the right answer. Okay, quickly. Yes, I'm waiting. MI Gamer has given the answer. Wrestling highlight, the answer that you are giving, it's not in any of the options. Okay, time is up. Now let's see what the correct answer is. So, okay, correct answer is 1000. And some are saying it's 10,000, some are saying 100, some are saying it's 1 lakh. And there is a very little margin between 1000 and 10,000. See, I told you, do the calculation carefully. Let's check the solution. So volume of boxes, simply you multiply all of them. That's L times P times H. Volume of blocks is again you multiply them. Units are different. So we divide volume of box with volume of blocks, right? And when you divide them, what do you get? You get 1000 over here, right? Yes. So 1000 is the right answer. Diksha is saying mine is correct. Nibha, misclick. Oh. Great. Simrat, 1000. Gungun, got it correct. All right. Let's take a look at the next question now. Now we have question number 3 over here. So curved surface area of a cylinder is 176 centimeter square and its area of base is 154 centimeter square. Find the volume of the cylinder in centimeter cube. Very simple one. Curved surface area is given, area of base is given, right? I hope all of you know how to do it, right? It's a simple one. But yes, these questions are actually time consuming, I would say, because calculation is involved. Lakshmi Jangir, yes ma'am. Good evening, Bhumika Sharma. V. Indra has given the answer. Lakshmi Jangir has given the answer. Yes. Okay. Quickly. Good evening, Praveen. Simrat Kaur. Okay. Time is up. Correct answer over here is 624. Though maximum students are saying it's 582. And just now also I saw in the chat that somebody has written 582, but that's not the right answer. See, mixed answers we have here, but maximum students have given the wrong answer this time. Let's check the solution and see where you got wrong. Area of base is given, that's 154 centimeter square. We know that we are talking about a cylinder, so its base area, it's basically a circle. That's pi r square. So substitute all the values. From here you get r square as 49. So r would be 7 centimeter. So you got the radius. Now when you have the radius, so curved surface area is 176 centimeter square. Curved surface area for a cylinder is 2 pi rh. Put everything here. The radius, pi value, from here you get the height, that is 4 centimeter. So volume in this case would be pi r square. That's how we find out the volume in case of cylinder. So pi r square value you already have, right? Area of circle. That's 154 times 4, that's 624. Vibha Chaudhary, great, you got correct answer. Very few students have given the right answer for this. Amarkant Divakar, okay. Kanika, mine is correct. Lakshmi Jangir. D, I just showed you the solution, Lakshmi. I hope your doubt is clear now. Yes, Vanya? Yes. All right, let's take a look at the next question now. So before that, let's take a look at the leaderboard first. Answer is not 616. I just showed you the solution. Vidit Kalra. Yes. Yes, so we can see that Rishika is at the top. Skids, Kanika Thakur, Heartstorm, Bill, Anjali Yadav, Earthman, Wolfmeister, Casper, Dr. Centipede. And I can see that initially there is a difference, there is a gap, and after that the gaps are also gradually reducing. Yes. 49th place, Papiya Das, not bad. Ruhi Gupta, 56th. Yes. Till now we have covered 3 questions, Amar. Alright, great. Let's take a look at the next question now. So we have question number 4 here. Yes, that's correct. There might be some calculation error. Yes, that's right, Dharya. So question number 4 you can see here. Find the ratio of lateral surface area and total surface area of a cube of length 6 centimeter. Very simple question, right? I remember that somebody asked me during the session when we are considering the ratios of the lateral surface area and total surface area. So I told you that time also that the value would be given in those questions. Something would be given, some information would be there. Okay, you already got the answer. Wow, very quickly. See, gradually your pace is also improving. Navdeep saying 1.34 seconds. Wow. But still some are saying it's A, some are saying it's D. Why this is happening? It's a simple one though. Mukesh saw, very nice, 0.603 seconds. So time is up. So correct answer for this question is 2 by 3. Some are saying it's 1 by 3, 2 by 5, 1 by 2. Yes, that was very easy. Not as such calculation was needed for that. Let's take a look at the solution. Lateral surface area is 4 times side square. So 4 times 6 square. Total surface area is 6 times 6 square, right? So that's, you put them in ratio. 6 square would cancel out and you simply have 4 by 6, that is 2 by 3. You do not have to calculate what is 4 times 6 square first and what is 6 times 6 square. That will only going to, then you're only going to waste time. Simply put them in ratio. When you put the values in the formula, cancel them out, you get 2 by 3. Correct. That's the right answer. Lakshmi, I just showed you how we are getting this. Yes. Amazing SK Cuber. 0.001 seconds. Wow. Awesome. Okay. So let's take a look at the next question now. That's question number 5. This is the last question of today's quiz, by the way. Okay. So 3 cubes of each volume. 125 centimeter cubes are joined end to end. Find the surface area of the resulting cuboid in centimeter square. Cubes we are joining together, just giving you a hint, right? So at the end we get a resulting, at the end finally we get a cuboid. We actually did a question like this in the session also today, if you remember. Yes. All right, some are saying C, some are saying D, very fast. Okay, SK Cuber has given the answer, Manasvi. Vanya. Yes. Another few seconds. Veer and Rishita has given the answer. Harinder, policy, pehle. Yes. Okay, so time is up. Let's check. Oh my God. You can see very little margins are there. Correct answer is 350. But some students are saying 340 and some are saying it's 350 and there is a gap of only one student you can see in between. Some are saying it's 300, some are saying 2800. That means you guys have a lot of confusion in this, right? Or maybe you have done some calculation mistake. Question is saying we are joining 3 cubes together, right? So you get a resulting cuboid. I showed you in the session also today that in such cases the length changes. Breadth and height will not change, right? And we visualize that as well, how it is happening. Volume is given for each cube, that's 125. And we know that volume for cube is side cube. So its cube root would be 5 centimeter. That's the side of cube. So when we have the side of the cube, we have length, breadth and height. Breadth and height would be 5 only. Length would be 5 plus 5 plus 5. That would be 15 centimeter. So we have the length now, right? And when we have the length, we can simply find out the surface area, which is 2 times LB plus BH plus HL. Put everything here, you get 2 times 175, that's 350 centimeters square. Yes, Vanya. Nibha Chaudhary, correct. Great. Sahil, no query, but time was less. Okay, so you need to work on your speed. And that can only happen when you practice a lot. Yes, only then you will be able to improve. Yes. Sonali Day, yes, right. Yes, okay. That's okay, Prakhar, it's fine. See, even if you're making mistakes, it's okay because we actually learn from our mistakes, right? And try not to repeat them next time. That's the more important thing. Time was less. All right. So this was the last question of today's Menti quiz. Now, time for leaderboard. Yes. So here, I can see that. Wrestling highlight. You enjoyed a lot? Yes? Great. Sorry, I won't be able to read out the name. There is some technical issue. The second place we have E.T., then Sri, then Saransh Kumar, Nishita, Diksha, Navdeep, Aditya. Yes, Gungun 58th place, Papiya Das 69th place. That's okay. Anish, junior 10th. Ruhi 56 to 41. That's good. Muhammad Anzar Khan 39th place. Wow. Alright, so this was the last question of today's quiz, but this is not the end because we have lined up many more sessions for you from every Monday to Friday to make you exam ready. Now let me give you a glimpse of the upcoming session. So tomorrow, that is February 8, Tuesday at 5 p.m. we will be having a session on surface areas and volumes, second part. Yes, so whatever 3D figures are left now that are a part of your syllabus, I'll be discussing them tomorrow. So make sure that you attend the class at 5 p.m. Yes? That's okay, Aman, because you joined late. It's fine. Yes, Ritik Bansal, tomorrow also we are going to have Menti after the session. Yes. Arush, you were at the first place. Dhairya is saying he was also at the first place. See, I was not able to read out, then I was not able to see the name due to some technical issue. Yes. All right. So please like, share and subscribe so that you get notified about the upcoming session. So I'll see you tomorrow. Till then, take care. Thank you.